All right. Question 2.9. We have a periodic signal xt. This signal is a square wave. It fluctuates between two values, a and minus a, from minus infinity to infinity. We know the energy of xt goes to infinity because it's periodic from minus infinity to infinity. But let's see why it is infinity. So first of all, I calculate the energy of the signal in a period. So this period, I calculate this energy of the signal in this period. You can take any other period, it doesn't make any change. So for example, you can take this period, or you can take this period. So you'll get the same result if you calculate the energy of the signal in one period. So I took this period. Let's see time at this point. The time at this point is minus 3 times t over 4, and time here is t over 4, and time at this point when the signal crosses the t-axis is minus t over 4. All right. Okay, and so let's calculate the energy of the signal in this period. We know this is the equation for calculating the energy of the signal. We calculate the integral of absolute of xt squared dt from minus infinity to infinity. But I want to calculate the energy of the signal in one period. Okay, so in one period, energy of xt, so I would write here in one period, is the same integral of the same function xt squared dt, but from this point here, which is minus 3 times capital T divided by 4 to capital T divided by 4. Okay, I can write this x of t in one period as sum of two integrals, from minus 3 times t over 4 to minus t over 4 of xt squared dt, plus integral of the same signal from minus t over 4 to t over 4. Okay, all right, here we have this definition in this period. The definition for xt is xt equals a if t is between minus t over 4 to t over 4, and is minus a for t between minus 3 over 4 times t. Okay, so let me rewrite that part again. Minus 3 times t over 4 smaller than t smaller than minus t over 4. Okay, so if I replace the value of xt here and here, we would have integral of minus 3 times t over 4 to minus t over 4 of minus a squared dt plus integral of a squared dt, which this equals a squared times integral of minus 3 times 3 times t over 4 to t over 4 of dt. Okay, so I'll write the rest here, and this equals a squared times t, because integral of dt is t, from minus 3 times t over 4 to t over 4. And if I calculate this, we would have a squared times t over 4 minus 3 times t over 4, which equals a squared times t. Okay, so this is the energy in one period. Energy in one period. And the periodic signal is a signal that fluctuates, that periodically repeats itself from minus infinity to infinity. So there are an infinite number of such periods here in yellow color. Okay, there are infinite number of these. So the energy of the signal then, the energy of the signal is infinite, the number of periods, which is infinite, times a squared t, which is infinite. And that's why we say the energy of the signal in the energy of a periodic signal is infinity. And that's only the case for the periodic signals, which are periodic from minus infinity to infinity. Okay, if a signal is periodic in a bounded time interval, then its energy can be calculated, and its energy is not necessarily infinite. Okay, infinite. So that's the energy of this signal. Let's calculate its power. For power of the signal xt, we have this this formula. This is 1 over t from minus t over 2 to t over 2 of xt squared dt. All right. So I removed all the stuffs here and rewrote the formula for power of the signal. And well, this formula is the formula to calculate the power of the signal, but for periodic signal we don't need to take the limits of the integral. We just calculate the integral in one period of the signal. So as I said, you can take any period you like, but I took the one you see here in yellow. So time at this point is minus, let me use different color, is minus 3 times t over 4, and time here is minus t over 4, time here is t over 4. Okay, so instead of calculating the power using this method, using this formula, I can, for periodic signal only, I can calculate the power of the signal like this. Integral of the signal from minus 3 times t over 4 to t over 4 of x of t squared dt times 1 over t. So I can write 1 over t behind the integral. So this is the formula for calculating the power of the signal for periodic signals. So we know that the signal xt is minus a in this period, and it is positive a in this period. Okay, so I can write the equation, the formula like this. Times integral of minus a squared dt from minus 3 times t over 4 to minus t over 4 plus integral of a squared dt from minus t over 4 to t over 4. Okay, so if I add these two up, this equals 1 over t times, and we previously calculated this part for the energy of the signal, and we know this equals a squared times t. Okay, so if I calculate this, then this equals a squared. So that means this is the power of this signal, this periodic signal.